Hello everyone, in this video I am going to talk about symmetric matrices and antisymmetric matrices. Symmetric matrices. Suppose that we have an n times n size square matrix A. If the transpose of A is itself, then we say that the matrix of A is symmetric matrix. Example, the matrix of A and B are symmetric matrices. Let's verify this. If we find the transpose of A, you know that to define the transpose of A, we write the rows of A as the columns of new matrix. It will be 1, 0, and 0, 3. As you see, this matrix and this one are the same. From here, the transpose of A is itself. And this shows that the matrix of A is symmetric matrix. A is symmetric. Let's look at the matrix of B. As you know, the transpose of B is, we take the first row as a first column, 1, 1, 0. Then we take the second row as a second column, 1, 4, minus 2, and third row as a third column, 0, minus 2, minus 3. This matrix and this one are the same. Then the transpose of B will be itself. From here, B is symmetric matrix. That's it. Exercise. Suppose we have the matrix of B, show that the matrices B times the transpose of B and the transpose of B times B are symmetric matrices. Okay, let's find the transpose of this matrix. Using the properties of transposition, this expression will be this one. You know that this is also B. B times the transpose of B. As you see, the transpose of this matrix is itself. You see, this expression and this one are the same. Because of this, B times the transpose of B is symmetric. Second one. Let's find the transpose of this expression. By the properties of transposition, this expression will be this. The transpose of B times this one. This is also B. Then the transpose of this expression will be itself. These and these are the same. From here, the transpose of B times B will be symmetric matrix. That's it. Antisymmetric matrices. Suppose that we have an n times n size square matrix A. If all diagonal elements of A are zeros and the transpose of A is minus A, in this case we say that the matrix of A is antisymmetric. Example. These matrices are antisymmetric matrices. Why? If we find the transpose of A, as you see, it will be this one. We write this row as a column, 0 minus 1, and this one as a second column, 1, 0. This. According to the constant multiple of matrix, this expression will be minus 1 times 0 minus 1, 1, 0. Instead of minus 1, I will write minus 0 minus 1, 1, 0. This expression is A, minus A. Okay, from here, the transpose of A will be minus A. In addition to this, all diagonal terms of this matrix are zeros. Because of this, the matrix of A is antisymmetric. Let's look at the matrix of B. We find the transpose of B. This is, we take first row as a first column, 0, 1, minus 3, second row as a second column, minus 1, 0, 2, third row as a third column, 3, minus 2, 0. This one. This is equal to minus 0, 1, minus 3, minus 1, 0, 2, 3, minus 2, 0. This one and this expression are the same. From here, it will be minus B. This shows that the transpose of B is equal to minus B, and also all diagonal elements of this matrix are zeros. Therefore, B is an antisymmetric matrix. That's it. Let's look at this exercise. Show that every matrix is a sum of a symmetric and an antisymmetric matrices. Here we mean square matrix. Suppose that we have an any size square matrix A. Let's write this matrix as 1 over 2 times 2A is equal to 1 over 2 times A plus A. And then we add and subtract the transpose of A, 1 over 2, A plus the transpose of A minus the transpose of A plus A. This is equal to 1 over 2 A plus the transpose of A plus 1 over 2 A minus the transpose of A. Here we use the notations B and C for these matrices. B is this one, 1 over 2, A plus the transpose of A. C is 1 over 2, A minus the transpose of A. If we prove that one of them is symmetric and another one is antisymmetric, then we will be to complete the solution. Let's find the transpose of B. The transpose of B will be the transpose of this expression. Here we use the properties of transposition. It will be 1 over 2 times the transpose of A plus the transpose of A is 1 over 2 times the transpose of A plus the transpose of A is equal to 1 over 2 times the transpose of A plus this expression will be A itself is equal to 1 over 2 A plus the transpose of A. As you see, this expression is B itself. Then from here, the transpose of B will be B. This shows that the matrix of B is symmetric. Let's find the transpose of C. The transpose of C will be the transpose of 1 over 2 times A minus the transpose of A. Is equal to 1 over 2 times the transpose of A minus the transpose of A is 1 over 2 the transpose of A minus the transpose of A is equal to 1 over 2 the transpose of A minus this expression is A. Instead of this expression we can write minus 1 over 2 A minus the transpose of A. But you see, this expression is C minus C. From here, the transpose of C will be minus C. From the previous lecture, you know that the trace of A is equal to the trace of transpose of A. Because of this, the diagonal terms of C will be zeros. These two conditions imply that C is antisymmetric. That's it. As you see, we can write A as B plus C, such that B is a symmetric matrix and C is an antisymmetric matrix. That's all. See you guys next lesson.